Hello, good afternoon again. Now, the next thing that we're going to look into is the product or multiplication of functions. So, in the multiplication of functions, there are again prior knowledge that we're going to recall. Definitely, the prior knowledge in addition and subtraction is applicable still in here. So, that is the same as the law of sine number. Now, another thing that we need to recall is the rules. Another things that we're going to recall is the loss, okay? Loss of exponents, okay? Now, in here, we just try to go over as fast as we can with the loss of exponent. In the loss of exponent, we have what we will now in here the product, okay? We have what we will be. Number one law is the same as the use of in here, x multiplied by x raised to n. This is actually the product law of exponent. Notice that in the product law of exponent, when they have the same base, we just copy the base and add the exponent. So in here, the result will be copy the base, okay? Copy the base, which is x, and then add the exponent, that is n plus m. Another one is we have in here that is the same as another illustration, a raised to n multiplied by a raised to m. Then a raised to p. So what would be the result? You notice that they have the same base. So the base is the this number. Okay, the base is the lower one, which is a. Now you notice that they have the same base. We will copy the base and then add the exponent. So that is n plus p. Now in here, we do not stop in here. If these are numbers, meaning to say we will evaluate, we will get the product. But if that is variable, it's fine. We will stop in here. So that is the product law of exponent. Another one is the power to power law of exponent, wherein it is represented by the symbol. Okay, the symbol. Power to power. So, n, an exponential number, being raised to another exponent. Okay? So, what would be the result? Meaning to say, we just copy the base and multiply their exponent. So, what would be the base of this exponential number? That is the same as x, and then raised to the product of n multiplied by m. Again, if it's our number, meaning to say, we comply with the dictate of the exponent, okay? We get the product. So if we are going to have this one, okay, the quantity x and raised to n, and then y, okay? So that is the same as raised to another exponent, that is the same as m. Now how is that? Same, still, we distribute. Okay, distributive property. Okay, so that is the same as x raised to nn multiplied, then y raised to n. So that one. Now another one is another law of exponent. Another law of exponent is for our number 3. For our number 3, we consider one in here. So we have in here the quantity a, b raised to an exponent, shall we say n. Now if we have this one as our notation, we just distribute the exponent. So the exponent would be, that is the same as, the result would be a raised to n, then b raised to n. Okay, so these are the basic loss of exponent that we need to consider. Another one, number 4, we say any number raised to 0. 0 is the number. Any number raised raised to 0 is another is any number raised to 0 is 1. Meaning, if I have in here x raised to 0, the result will always be 1. If I have in here the quantity x plus y raised to 0, the result will always be 1. If I have 1 million, okay, 1 million raised to 0, the result will always be 1. Okay? So these are the things that we need to consider. Another one is, of course, we have in here, that is the same as, shall we say, number 5. Any number raised to 1 is the number. How is that? We have in here an example. X raised to 1. X. Fine. Raised to 1. Fine. Shall we say, we have in here the quantity x plus y raised to 1 is the same as x plus y. And so that is the idea. So we have a lot of loss of exponent, but in here we will use first this one before we look into the other loss of exponent. In the multiplication of function, definitely we have to have this notation. The product of f function and g function of x will always be f of x then g of x. Okay, so that will always be the result. Say for example, if we have a function which is number 1, f function is defined by shall we say x plus 5, and another function that is g function being defined by shall we say x raised to 2 plus 4x plus 4. Now, how do we get the product? So to get the product in here, we need to recall not only the loss of exponent but the distributive properties, or the distributive property. That is the same as saying we found this one. Okay? So what would be the product of f of x multiplied by g of x? So we follow this pattern. So that is the same as saying f of x is defined by x plus 5, which is the quantity x plus 5, multiplied by g of x defined by g of x, that is x raised to 2 plus 4x plus 4, multiplied by x raised to 2 plus 4x plus 4. Okay, in here we will distribute. Okay, so how do we multiply? Let's try to multiply. This is the same as x multiplied by x raised to 2. We have x raised to 3. X multiplied by 4x, we have 4x raised to 2. X multiplied by 4, we have 4x. Okay, how about this one? We multiply. So 5 multiplied by x raised to 2, that is the same as 5x raised to 2. How about this one? That is the same as plus 20x. How about this one? That is the same as plus 20. After having the multiplication, that's the time we're going to combine similar terms. So if this is alone, x raised to 3 is alone, we just copy that one. That is the same as x raised to 3. And what about this one? What are the variables with the same, what are the terms with the same exponent and variables? So we have in here 5x raised to 2 and 4x raised to 2. So it will give you that is the same as 9 x raised to 2. Now what about this one? Are they similar? Yes, they are similar, and so that is the same as plus 24x. How about the numerical, this one? Here, so that is the same as plus 20. And so the product of f function and the g function is equal to x raised to 3 plus 9x raised to 2 plus 24x plus 22. And so this would be the result. Yeah, this would be the result. Now, what about if we are going to have the other example? Okay, let's try to have in here. So we have in here number 2. Number 2, our h of x is defined by 1 over x minus 1, and another function which is g of x is defined by x raised to 2 minus 2x plus 1. In here, what will be the product? And so let's try to have the notation. Notation for the product of the function, that is the same as saying h and g function of x, okay, their product must be h of x and then g of x. So we follow this pattern. So that is the same as saying, what is the h of x? H of x is 1 over x minus 1. Okay? Then what about the g of x? The g of x is the same as saying, we have in here x raised to 2 minus 2x plus 1. Now in here, for us to get or to simplify or to, for us to get the product, now we need to get the factor of this trinomial. Now what is the factor of this trinomial? Considering that that is the same as perfect square, the factor are the following, okay? That is the same as x minus 1 multiplied by x minus 1. And so notice that when we have this factor, it will give you now, let's multiply, that is the same as x plus minus 1 multiplied by x minus 1 over x minus 1 will give you now a result of just x minus 1. And that is the product of h of x and g of x. So the result will be x minus 1. Thank you.